Hi, I'm Kay Crail from Sundance DSP, and I would like to demonstrate how an application with DSP and FPGA pre-built tasks could be created using PARs. Pre-built tasks could be considered as black boxes supplied by third parties or as driver tasks for I/O devices supplied by hardware manufacturers. For example, if there is an ADC module connected to an FPGA, for setting up the ADC module, the hardware supplier may provide an FPGA IP core, which will simply run on the FPGA for this purpose. In such cases, we need to first develop an application using signal sources and sinks supplied by Sysgen, HDL Coder, or other toolboxes before using the pre-built tasks, as when we introduce the pre-built tasks in the model, then we lose the ability to simulate unless a Simulink block for the pre-built task is also available. Note that pre-built tasks have an X on the block for distinguishing them with other blocks. The task image files for FPGA and DSP pre-built tasks are copied under the folders shown in the video. When creating DSP pre-built tasks, care should be taken with data types for input and output ports. For example, here the SMT350 capture task has data type INT32 for output port 1. Therefore, the input port 2 on the control task should have the same data type. This is shown in the video. In this demo, we make use of the SMT350 ADC DAC module, which is plugged on top of the SMT368 FPGA module. All of the DSP and FPGA tasks are pre-built tasks except for the FFT and scope blocks. The DAC is fed with two sine waves generated by the DDS task. These channels are then looped back to the ADC input channels. The digitized data is sent to a DSP pre-built task, SMT350 capture block. One set of the captured data is fed to the scope directly, and the other set passes through the FFT blocks. As shown in the video, the DDS, DAC-DP, FPGA pre-built tasks are driven by the DAC clock, and the ADC-DP high-speed channel are driven by the ADC clock. The ADC and DAC clocks are described in the diamond configuration block as shown. For more information on clock description, please read the Diamond User Guide. Also, remember to declare the channels between the DSP and FPGA tasks. The high-speed channel is described using the Connect To and Connect From blocks. These blocks can be used when communicating with a non-Sundance I/O device. Now save the model and close it. Open PARS window and select the Hardware System in PARS options. In FPGA Task Generation, select Automatic, as we are using pre-built FPGA tasks. Press Accept. Open the model in PARS. Select each FFT blocks and make a subsystem out of them. Also, select all of the scope blocks and create a subsystem. Make DSP tasks out of the FFT subsystem in PARS and host subsystem from the scope blocks. Now press the play button in PARS. This will generate the DSP code for the FFT blocks and start generating the bit stream for the FPGA. As this takes some time, you may want to fast forward it. When the application is built, PARS will come up with a window system generated successfully, as seen in the previous videos. Click OK and change the configuration parameters in the test bench as before. Press play and select the Sundance Carrier Card SMT 310Q. You should see 4 scopes popping up. Select each scope and auto-scale the windows as shown. Two original sine waves and 2 FFTs should be displayed as shown. Save the test bench for future runs and exit. This concludes the demo with pre-built tasks. Thank you for your attention. Please contact us for your comments and questions.